हेलो एवरीवन, गुड इवनिंग, हाउ आर यू? कैसे हैं आप लोग? राइट, होप आप लोग सब अच्छे होंगे. राइट, वी हैव ऑलरेडी डिस्कस्ड अबाउट द डिजिटल, दैट इज द सेशन ऑफ द बार्क CS branch, right? BARC especially for the CS branch, and the subject is nothing, it is just a digital electronics, right? So you all are aware about the digital electronics. We have already taken the one session in the yesterday, and in this particular session we have discussed about what the number system, few questions related to the number system and the combinational circuit, right? In this session mainly we are going to deal with the sequential circuit, right? So you all are aware about the sequential circuit, right? Before going to start the sequential circuit, I am just give you the brief idea about the sequential circuit. Sequential circuit is a circuit in which the output depends on input, the output depends on the present as well as the previous state of input, right? It means the sequential circuit is a circuit in which the circuit having the feedback or the output depend on the what? Present as well as the previous state of input. Whereas in the sequential combinational circuit, there is no feedback present, right? So in the combinational circuit, the output depends only on the present state of input. If you are applying the input, then only you will get the output, right? It will never store the any output. But in the sequential circuit, generally it is used to store the bits, right? And the topic of the sequential circuit for the CS branch, there is only 4 topics is important for the sequential circuit. In the sequential circuit, the first one is the latches. The second one is the flip-flops. Third one is the registers, and the fourth one is the counter. That is the important topic for what? That is the important topic for the sequential circuit for the CS branch, right? And definitely we can expect most of the question in the digital electronics from this topic only, right? In the sequential circuit, first the latches is nothing, it is just a level triggered. But whereas in the flip-flop, if you want, the flip-flop is nothing, it is just a what? The edge triggered. So that is the difference between the latches and the flip-flop. And my dear friend, the latches is the basically basic memory element of the any memory device. That is the latches. You all are aware about the latches, right? Now, first question I am giving you in front of you, that is related to actually the registers, right? That is related to the register, right? And it is nothing, it is just a symbolic representation of register. We know that there is a 4 type of register, right? Shift register, right? I'm just generally dealing with the shift register. There is a 4 type of shift register: serial input, serial output shift register, serial input, parallel output shift register, parallel input, serial output shift register, and the PPO. In the last, there is the PPO, parallel input, parallel output shift register. PPO is the fastest shift register among all the shift register, whereas CISO, serial input, serial output shift register, is the slowest shift register among all the shift register, right? So my dear friend, the first question in front of you, everybody just give me the answer, right? The initial content of the 4-bit serial in parallel out, right? It is a SIPO shift register, right? Serial in parallel out shift register. Parallel out, right shift, right? So data will be shifted to the right hand side, right? So data will be shifted like this, from there to there. After that, this, like this, whenever the clock is applied. And yes, my dear friend, the shift register is nothing, it is just a what? It is a synchronous, right? It is a synchronous device. Synchronous device means all the flip-flop, it is just generally DA flip-flop. So all the flip-flop are connected with the same clock. It means whenever the clock is applied, all the flip-flop work simultaneously, and the data which is present to the input of that flip-flop will be directly moved to the output of that flip-flop, right? That is the basic thing. Now, my dear friend, what is basically the question? The initial content of the 4-bit SIPO shift register, right shift registers shown in the figure. Initially it is noted 000. Initially it is content 0110. After the 3 clock pulse are applied, the contents of the shift register will be. Okay, everybody just give me the answer for this, right? Respond for this question. Very easy question, right? And yes, in the BARC we can expect this type of question. Not that much of tough question, right? But yes, the previous year gate question we can expect in the BARC, right? They are repeating. So just go through the previous year gate question also. It will be helpful in the examination during the BARC exam, right? Okay, everybody just give me the answer of this question. Very good, excellent. So my dear friend, for this question, if you want to solve, first I am giving you the clock will applied. Here I am saying it is a clock, and it is nothing, it is just a Q1, Q2, Q3 and Q4, right? Now my dear friend, we know that initially all the flip-flops are not in reset condition. Initially the clock is basically up, right? Initially the data stored is different. So when the no clock is present, then the data is stored, it is 0, 1, 1, 0, right? I'm taking this one as a MSB, this one is a LSB, right? Now, what happened to the first clock? So my dear friend, it is a XOR gate. You know the principle of the XOR gate. What is the principle of the XOR gate? So in the XOR gate, whatever the input, whenever the input are same, the output is 0. The output is 1 only when the input are different. and at this time we can say that 1 and 0 the input are differ. If the input are changed, then of course we can say that the output is nothing, it is a 1. So my dear friend, whenever the clock is applied, that 1 moves to this position, that 0 moves to this position, that 1 moves to this position, that 1 moves to this position. So all the flip-flop works simultaneously, right? Because it is a D flip-flop. So data transfer basically done in this principle, right? So 1 is basically introduced. Now that 0 is introduced to this position, that 1 is introduced to this position, and that 1 is introduced to this position. So after the clock pulse, first clock pulse, the data is basically looking like this. After the first clock pulse, the data is 1, 0, 1 and 1. Now my dear friend, it is a 1, 1. Of course, in the XOR gate, wherever both the input are same, either 0, 0 or 1, 1 or the same variable, then the output is 0. So now when the second clock is given, that 0 is introduced to the circuit. So if the 0 is introduced, then 1 is shift to this position, that 0 is shift to this position, that 1 is shift to this position, because it is a shift register. And it is a serially shift register, so data will transfer serially. Now for the third. Now what is the basically condition? Sir, condition is it is a 0, it is a 1, it is a 0 and it is a 1. Now 0, 1 again, here you can feel, here it is nothing, it is just a 1. So my dear friend, when the third clock is given, that 1 is introduced, that 0 moves to this position, that 1 moves to this position, that 0 moves to this position. And now the question is basically giving what? After the 3. So after the 3 clock pulse, the state is nothing, it is a 1, 0, 1, 0. So 1, 0, 1, 0, which option is 1, 0, 1, 0? So 1, 0, 1, 0, C is the correct option, right? So very easy question. And now I am giving you one more question, right? After 137 clock, after 137th clock, you have to find out the output, right? That is the homework, right? After the 137th, what is the basically after the 137th? And you do not require to move or provide the clock till 137. After some time you will feel the symmetricity will be occur, and when the symmetricity occur, then by the application of that symmetricity you can find what is the basically the output after the 137 or 512 or whatever the basically question they will ask, right? So this type of question we can expect. Excellent, right? Now my dear friend, the next question in front of you, right? That question, everybody, are you convinced with this or do you have any doubt in this particular question, right? Okay, very good. Now the next question in front of you. Everybody just give me the answer of this question, right? Right, very good. What is the question? The input A and clock applied to the D flip-flop. It is the clock and it is the A is applied to this clock, right? This flip-flop. And D flip applied to the D flip-flop are shown in the figure below. The output Q we have to find out. Which of the waveform is matched with the Q? Everybody just give me the answer for this, right? Very easy question, not that much of tough question. We know that. Okay, can anybody give me it is a flip-flop or it is a latch? Sir, of course it is a flip-flop. It is not that because of it is mentioned in the problem, just because of the clock, right? It is a clock and we can say that it is nothing, it is just a positive as triggered, right? Positive as triggered. Or rising, we can say that the rising triggered, right? There is the two A's now, right? Rising A's and falling A's. So we can say that it is a rising as triggered, right? Or positive as triggered. It means whenever the clock you feel, and if it is connected like this, if it is a D flip-flop and it is a connected like this, right? So it is a level triggered. So if it is a level triggered, then my dear friend, it is not a flip-flop. It is what? It is a latch. It is a latch. Okay, now we know that it is a flip-flop. Yes, everybody has given the correct answer, of course. What is the D flip-flop? So D flip-flop is a flip-flop in which whatever the input is applied, the D flip-flop is a flip-flop in which whatever the input applied, it will directly move to the output along with the clock, right? So you have to apply the clock only, and whatever, either the 0 or 1, whatever the input is, it will move to the output along with the clock. So my dear friend, if you want to find out the output of this particular flip-flop, then my dear friend, just listen. And that output will be shifted to the that input will be shifted to the output only when clock is applied, and clock is positive as, so positive means what? 0 to 1. So my dear friend, it is 0 to 1, it is 0 to 1, it is 0 to 1, it is a 0 to 1. So the transition of the output from input to transition of the input from input from to the moves from input to the output will occur only in this particular as, right? Now it is the A flip-flop. So my dear friend, till this clock is not applied, all the flip-flops are in basically the reset condition, right? So I'm saying the flip-flop is nothing, it is just in reset condition. Now, when whatever the input is applied, right? So when this age is given, when this clock is given, then whatever the input, it will move to the output. So input is 1. so it will move to the output 1. And now clock disappear, so it will maintain that 1 value. Now here the clock is given. Now what is the input? Sir, input is 0. So when this clock is given, then 0 will be moved to the output. So output you will feel 0. Right? After that, this is the positive S. What is the data? So data is 1. So at this particular S, if the data is 1, then that 1 will be moved to the output side. So at this time, 1 will be moved to the output side. After that, here we can say that it is a rising S. What is the data? So data is 0. So at this particular instant, 0 is transferred to the output. So you will feel the output, there will be 0. Of course, there is the propagation delay also. You can never find that type of sharp signals, right? But we are not considering here the propagation delay because that propagation delay is not mentioned in the problem, right? Of course, there is the propagation delay, right? Now, my dear friend, the output of this one is nothing. It is just like this. Just match it. Sir, B is the same like this, right? B is the same like this. So, of course, B. Which one is correct? Sir, B is the correct for this. Excellent, right? Excellent. Now, my dear friend, now next question in front of you, right? Everybody just give me the answer of this question. It is again related to the number system, right? And what they are asking, the radix complement we have to find out. The radix complement we have to find out for this particular question. Just give me the answer. For the radix complement, just give me the answer of this, everybody. Okay, very good. We know that there is a 2 complement only, right? The one is the R minus 1 complement, R minus 1's complement. And the second one is what? R's complement. There is only 2 complement. Right? And that complement we are calculating only for R minus 1 complements. Every time we are calculating only R minus 1 complement. For example, 1's complement we are counting, right? We are calculating always 1's complement, 3's complement, 5 complement, right? 9's complement, we can say that. And whenever you want the even number of complement, right? Then first find, if you want to 6 complement, first find the 5's complement. And after that add 1 in the LSB, you'll get the answer, right? And how you'll get the complement? Everybody just listen carefully. If I'm saying, if you want to complement, if I'm saying the data is written 1, 4, 3, and I'm saying just find the 5's complement of it. Find 5's complement of it. Before doing this question, everybody just listen. 5 complement. Everybody has given the correct answer, right? So that's great, right? 5's complement. Whenever you want to find out the 5's complement, just write the 3-bit number of the 5 and maximum number is 5. So my dear friend, I'm saying 5, 5, 5, right? That is the maximum number. And subtract 1 over 3 from this. You'll get the answer. It is 2, it is 1, it is 4. You'll get the answer this. And it is called 5's complement. The 5 complement of 1, 4, 3 nothing, it is just a 4, 1, 2. And if you want to find out the 6 complement, just add plus 1 in the LSB. You'll get 3, 1, 4. It is the 6 complement. So first always try to solve the R minus 1's complement. After that add 1 in the LSB, you'll get the what? R's complement for this. In the same problem, right? So my dear friend, we are not able to solve direct the 16th complement of this. Yes, we can do. But at this moment, we are not solving this. We are doing the 15th complement of this. And how to find out the 15th complement of this? Because base complement we want. The base is 16. So 16 complement we want to find out. So first I'm finding the 15th complement, right? How you'll find out the 15th? There is the 4 digits. So F maximum number of 15, right? Base 16 is from the 15th complement, that is F. Subtract 7F01 from this. F, it will become E. It will become F. It will become 0. F minus 7, you will get 8. So it is called what? It is called 15th complement of 7F01. So my dear friend, the 15th complement of 57F01 is nothing. It is just a 80FE, right? But they are not asking about this. They are asking about the 16th complement. So my dear friend, they are asking about the 16th complement. So how to find out the 16th complement? Just add in plus in LSB. E plus 1 F08. So the answer is 80FF. Of course, the B is the correct option. Right? B is the correct option. Right? Everybody, are you getting my point? And already you have solved this question, so that's great, right? Now we are moving on the next question in front of you. Everybody just give me the answer of this question, right? Everybody just give me the answer of this question, right? The two D flip-flops are shown below are to be connected as the synchronous counter that goes through the following Q1 and Q0 sequence, and that sequence will be given 0 0 to 0 1 to 1 0, after that 1 0, after that 0 0, and so on. The input D0 and D1 respectively should be connected as. It is nothing, it is just a question related to the synchronous counter design. It is the question related to, my dear friend, the synchronous counter design. How to solve this question? Everybody just respond. And how to, what are the basically step to design the synchronous counter? If you want to design the synchronous counter, 5 steps you have to follow, right? The 5 steps you have to follow. What is the first step? The first step is nothing. Find the previous and present state. Find the previous and present state. That is the first step. The second step, right? Second one. Write the excitation table of flip-flop. From which flip-flop you want to design that counter, we have to find out we have to write the excitation table of that flip-flop. After that, third step, write the logical expression. Fourth step, minimization, and the fifth step, hardware implementation. If you do these 5 steps, you are able to solve all type of synchronous counter design. So yes, of course, few people has given the correct answer for this, right? Very good. So if you want to solve this question, everybody just listen. If you want to solve this question, how to solve this question, right? From D flip-flop you want, and Q0 is given as a LSB. So my dear friend, it is a LSB, it is MSB, right? So first I am writing Q1, Q0. That is the first step. The normal sequence I am writing. How to solve this question? Very easy question actually, right? You all are aware about this. Q1, I am writing Q1 plus, that is the next stage, Q0 plus. And after that, excitation we required, so I am writing D2. D2 and D1. Oh, sorry, D1 and D0. Right? So, my dear friend, yes, the first I am writing what is the state? It is given what the counter we have to design. I am writing only the sequence, nothing else. 0 0, 0 1, 1 0, and 1 1. By 2 bit, we can write likely, or the simple sequence is that, right? But what they are asking, after the 0 0, we want 0 1. So after the 0 0, the next state should be not 0 1. The next state, yes, that next state should be 0 1. After the 0 1, the next state will be what? 1 1. So after the 0 1, the next state will be 1 1. After the 1 0, the next state will be what? 0 0. So after the 1 0, the next state will be 0 0. I am writing 0 0. Right? Now after the 1 1, sir, after the 1 1, the next state is 1 0. So we are writing the next state. This is the general sequence, the normal sequence I am writing, and this one is nothing. It by the table, by the question. What is the next state after 0 0? What is the after 0 0? It is 0 1. So I am writing 0 1. After the 0 1, it is 1 1. So I am writing 1 1. After 1 0, there is the 1 0. So after 1 0, 0 0. So I am writing 0 0. After 1 1, sir, 1 1 1 0. So I am writing 1 0. That's it, right? Now if we want to write the condition for that, what is the D1, right? So for D1, if you want, so D1 is nothing, it is just an excitation table we want, right? We have already written the previous and present step. Now we want to write the excitation table. So for the D flip-flop, the next state itself is a excitation table, right? Qn plus 1 equal to D, or D equal to Qn plus 1. So just copy the Q1 plus into the D1 and Q0 plus into the D0, right? You will get the what? Excitation table of D flip-flop. It is very easy, right? So it is 0, 1, directly copying on this one. And here you will get 1, 1, 0 and 0. It is like that, right? Now my dear friend, if we want to solve this question, now D1 and D0 and D1 they want, right? So what is D1? So if we want to find out the D1, write the D1 equation for Q1 and Q0. So write the equation for the D1, which is the function of what? Q1 and Q0 only, right? And write the equation of D0, which is the function of Q1 and Q0 also. So first I am writing for D1. D1 is nothing, it is just a what? First D1 or D0 I am writing. First I am writing D0. D0. So my dear friend, D0 is nothing. These two are basically connected. So I am writing Q1 bar, Q0 bar plus Q1 bar, Q0, right? And just take the Q1 bar common. We have to minimize it also now. So D0, if you want, D0 is nothing, it is just a Q1 bar I am taking. and Q naught bar plus Q naught. So anybody just give me the answer, Q naught bar plus Q naught? Yes, of course, all are aware 1. So you will get the answer Q1 bar. So D naught equal to Q1 bar. Now I am writing for the what? D1. D1 for this, right? It is a D1. This one and this one. Write the expression. So D1 is nothing, it is just a what? Q1 bar Q naught plus here Q1 Q naught. Q1 Q naught. Now I am taking the Q naught as a common. So Q1 bar plus Q1, it will become 1. Directly I am writing the answer Q naught. So my dear friend, D naught is nothing, it is just a Q naught, Q1 bar, and D1 is Q naught. So of course the A is the correct option. Q1 bar and Q naught. Right? Everybody has given the correct answer, right? Very good. So this type of question we can also expect. So D naught, right? So D naught we can connect to the Q1 bar. D naught we can connect to the Q1 bar for this sequence counter, and D1 should be right Q naught. It is a counter we have designed, or we can say that, my dear friend, it is nothing. It is a Johnson counter, right? The name of this counter is Johnson counter. Johnson counter, right? There is a synchronous counter. There is a two type of synchronous counter, ring counter and Johnson counter. So it is nothing, it is just a Johnson counter. And the Johnson counter having the 4 another name, right? The first name is the Johnson counter, second name is two-state ring counter. Because if you will connect from Q1 to Q naught, D naught, it will become what? It will become, okay, MSB, LSB order change, na? So I'm not saying the Johnson counter. Because there should be, this should be MSB, this should be LSB. Then we can say that it is nothing, it is just a Johnson counter. Here the sequence is changed. Yes, it is not a Johnson counter. It is a Johnson counter when this is MSB and this is LSB. Then we can say that it is a Johnson counter, right? Now, for the next question in front of you, everybody just give me the answer. For this question, right? It is also related to the synchronous counter because all the flip-flops are connected to the same clock. That's why it is called synchronous, right? Now, just give me the answer of this question. What are the counting state Q1 and Q2 for the counters shown in the figure? Everybody just respond for this question. Respond karo beta. Okay. If you want to solve this question, J1 and K1 are connected to Q2 bar, right? And J2 is connected to Q1 bar and K2 is always set to the 1. Now, my dear friend, Q1 and Q naught, it is given Q1 first, Q1 after that Q2. So Q1 will become what? MSB and Q2 will become LSB, right? It is in this order. So, my dear friend, I am saying Q1 and Q2, right? I am writing Q1 and Q2. And after that I am saying it is the clock. Right? Now when the clock is not given, I am saying all the flip-flops are in reset condition. If the flip-flop is not connected, all the flip-flops are in reset condition. I am just considering this. So my dear friend, if it is a reset condition, it will become 0. It will become 0. If it will become 0, of course, it will become 1. And if it is become 0, it will become 1. So my dear friend, it is in the J and K. Both are connected to 1. Here J and K both are connected to 1. And for the JK flip-flop, we know that whenever all the input are connected to J and K equal to 1, then the flip-flop works in the toggle mode. We have to apply what? We have to apply the clock. When you are applying the clock, the flip-flop itself changes the output of the previous state, right? Previous state is already changed and always changed, right? It is called the toggle mode. So my dear friend, this flip-flop also want to work into the toggle mode. This flip-flop also work into the toggle mode. So if you apply the clock, as we know that it is a synchronous counter, all the flip-flop works in the simultaneously and all the flip-flops output will change, right? Simultaneously. So my dear friend, when the clock is connected, when the clock is applied, then my dear friend, all the flip-flops are basically changed and its previous state. All the flip-flop will change to its previous state. What is the previous state? So both are initially reset. If both are initially reset, then it will become set. It will become set. Right? Because both the flip-flops are working in the toggle mode, right? Of course. Now, if it will become 1, then it is 0. If it is 1, then it is 0. Now my dear friend, we can say that j equal to k equal to 0, and here we can say that j equal to 0, k equal to 1, right? Now for the flip-flop, we have to command on the particular in the flip-flop for the designing of the counter as well as the register also, right? So j equal to k equal to 0, j equal to k equal to 0, it means it will hold its previous state. It will hold its previous state. And j equal to 0, k equal to 1, it means it reset its previous state. So my dear friend, this flip-flop want to reset its previous state. Reset its previous state means reset its output. So my dear friend, this flip-flop want to make this one 0. And this flip-flop hold its 1. So this flip-flop holds its 1. But for holding this one and for making this one 0, it required clock. So when the second clock is basically applied. So when the second clock is applied, first clock, I am not writing the condition, I have forget to write. The first clock, both the flip-flop will become output 1, 1. Now for the second clock, if you want, this flip-flop holds its state. So this flip-flop holds its state, and this flip-flop make the output reset 0. So this flip-flop make the output reset. Now my dear friend, for the third clock. Now my dear friend, for the third clock, everybody just listen carefully. Now what is the basically condition after the second clock? After the second clock, the condition is it is 1 and it is 0. If it is 0, it is 1. If it is 1, it is 0. It is 0 and this one is 1 and 1. This flip-flop want to toggle its previous state because j equal to k equal to 1. Toggle its previous statements is want to this one as a 0. But it will do that one, or it will change that one to the 0 only when the clock is applied, right? For this, it is a j equal to 0, k equal to 1. It want to make the output reset. So it is already reset. It does not make any difference. But it want to make the output reset. But it required what? It required clock. So my dear friend, when clock is applied, then my dear friend, it want to toggle its state and it want to make a reset. So toggle means 1 to 0, that 0. So both 1 to 0 and 0. So I'm writing it will become 1 to 0 and it will hold that 0, right? Everybody just listen carefully, right? So my dear friend, it will become 0, 0, right? Now, okay, yes, in the A option, there will be some mistake. I'm just correcting it. Everybody just forget about the option because the how to solve this type of question, that is the important part, right? 0, 0. Now when the fourth clock is given, right? Hope that will be the, that is the answer. Yes, right? So in the fourth clock, again, it will start and it will become what? 0, 0. After the 0, 0, it will become 1, 1. After that, 1, 0, like that, right? So my dear friend, it is nothing, it is just it is like this. It is only the 0, 0, right? So my dear friend, if you'll see, after the 0, 0, it will saying 0, 1. But 0, 1 is not present in the state, right? Am I right for this? So 0, 1 is not present in the state. So my dear friend, this one is wrong. This one is wrong. This one is wrong. Of course, the A is the correct answer of it. Right? A is the correct answer because either if you will see the 0, 0 to 1, 1, after that 1, 0, after that 0, 0, after that 1, 1, either you will go with this sequence or you will go with this sequence. The pattern will be like this. That's why the correct answer for this question is A is the correct answer, right? Everybody, are you getting my point? That's very good, right? Now, next question I'm giving you in front of you. Everybody just give me the answer of this question. Find the mode of the counter when initial flip-flop stores the value 101. So my dear friend, we have to find out the mode of the counter. It is also a counter, but it is stored, initially it is stored with 101. Can anybody give me the answer for this? Because you have already studied about this one. It is a very easy topic, right? Everybody just give me an answer for this, right? Very good. Of course, if you know this circuit, it is nothing, it is just a symbolic representation. It is nothing, it is just a symbolic representation of Johnson counter. Of Johnson counter. Right? And we know that the Johnson counter having another name also. What is the name of the Johnson counter? First name, Johnson counter. Second name, creeping counter, twisted ring counter. Third name, creeping counter. Fourth name, Mobius counter. Fifth name, walking counter. So there is a 5 name of the Johnson counter. Again, I am repeating. Johnson counter, twisted ring counter, creeping counter, Mobius counter, walking counter. All are basically belongs to what? The Johnson counter. Now, my dear friend, in the Johnson counter, we know that if there is the n-bit Johnson counter, then the mode of the counter is 2n. So it is a 3-bit. So it is a 3-bit. So mode of the counter should be 6. Right? But only the 6th state is present. There is 2 state is not present, or which is not a part of the Johnson counter. Which is 2 state? That is 0, 1, 0 and 1, 0, 1. Right? Because by the 3-bit, there is a total 8 condition are possible. Right? And Johnson counter using out of 8, they are using only the 6th state. That's why the mode is nothing, it is just a 6. Which state they are not using? So it is not using the 0, 1, 0 and 1, 0, 1. And in the Johnson counter, already unused states is basically stored. So my dear friend, it is called the lockout problem. Lock. L-O-C-K-U-T. Lockout problem. It is called lockout problem. Right? What is the lockout problem? Whenever the Johnson counter enters into its unused states, then it will trap into its unused states, and that is called the lockout problem, right? Now my dear friend, if you want to find out actually the output, it is the clock. I am saying it is nothing, it is just a Q1, Q2 and Q3. If the clock is not applied, it will store 1, 0, 1. So what is the opposite of 1? Sir, opposite of 1 is 0. So whenever the first clock is given, that 0 is introduced to the flip-flop. So that will become 0, and now this 1 is shift to this position, this 0 is shift to this position. Because this is also a shift register. Right? But the feedback is connected to the NOT gate. That's why it is looking like this. That's why it is called the Johnson counter or twisted ring counter. Now, when the second clock is given, now my dear friend, if the state is nothing, it is just like this, right? So after the first clock, you will feel the state is nothing, it is just a 0, 1, 0. What is the opposite nature of the 0? So if they invert the 0, it will become 1. Now, when the second clock is applied, then my dear friend, that 1 is introduced to the flip-flop, that 0 moves to the next position, that 1 is moved to the next position. So 1 is introduced, that 0 is next position, that 1 is next position. Again that will, for third, again you will feel it is 0, 1, 0. For the fourth, again you will feel 1, 0, 1. So my dear friend, even we know that it is a Johnson counter, it should have the 6th state, mode 6. But even we can say that it is initially store that value which is the unused states of the Johnson counter. That's why it will trap into these 2 states, unused states, and this is called a problem, lockout problem. So my dear friend, initially the phase should be that mode should be 6, but as we know it suffers from the lockout problem. That's why the phase should be nothing, it is just a what, or mode should be nothing, it is just a what, 2. You can say only these 2 values are basically repeated. So mode of this value is nothing, it is just a 2, right? So hope you all are aware about this problem, right? Now my dear friend, that is nothing, it is just a digital. Hope you will enjoy that class, right? And you learn something new, right? So all the very best. Prep smart, score better, go Gradeup.